Good, how are you?
Very good, very good.
Looking forward for your presentation.
Thank you. How's the event going so far?
The event is going pretty good so far. Thank you.
Excellent. Wonderful, wonderful. Well, thanks for moderating this one.
Yeah, you're very welcome. So yeah, folks, we are about to start our next presentation by Mr. Venkat. And you are still encouraged to ask all your questions in the Slack. And I think Venkat prefers to do them as we go. So I'll be probably interrupting if you prefer, or raise a hand and shut the question right away. So yeah, I will wish you tons of luck. So yeah, the mic is yours.
Thank you so much. I really appreciate it. Well, thank you so much for everyone who joined. I really appreciate your presence here. Let's talk about what we're going to, spend the time on, and then we'll dive in. I want to talk about reasons and ways to improve code quality. We'll talk a little bit about code quality itself. We'll talk about the reasons to improve the code quality. And then I'll talk a little bit about things that we can do to really improve the quality of code. The best time to ask questions or make comments is anytime you have a question or a comment. So please don't hesitate. Anytime is a good time for your questions, your comments, and of course, I will respond to them along the way. So let's get started. Well, the first question I want to start with is, what is quality? And if you ask different people in your organization, I'm sure you're going to get very different answers to that particular question. And that's perfectly fine. We all may perceive quality in very different ways. I remember very clearly once working with the team when I was mentioning that the quality needs to be really improved, when a group of developers got together and said, what do you mean? We think the quality is really good. Why do you think we should improve it? Well, that's when you begin to realize that we all see quality very differently. I would take almost any answer somebody gives, except one answer I got from a developer, a while ago, and he said, "This code is great because I wrote it." Well, I don't think that's a good definition of a quality. A quality cannot be based on who is actually writing it. So here is my definition of what a good quality code is. I will say the quality of code is inversely proportional to the effort it takes to understand it. So if we write a code with really good quality, it'll take less time to understand it. If we take an effort to understand it, and if we write a code with poor quality, it takes more time and more effort to actually understand the code. So I would argue that the quality of code is really a way to measure it, if you will, is based on the effort to understand the code in general. So and of course, when we say effort to understand it, there is an underlying assumption there that the person who is trying to read the code is somewhat familiar with the context of application building. They are familiar with the domain reasonably, they're familiar with the application reasonably. It could be you who has written the code, but months later trying to really look at the code. How many times have we looked at our own code and not understanding it? And so this is exactly the reason why we want to improve the quality of code. But why should we focus on the quality of code? And I'm a big fan of the why question, because if we can answer the why, I think we can then get really good at being motivated to really do something. So why should we really care about the quality of code? Well, the first law of programming says the following, and that is lowering a quality lengthens the development time. So essentially, this is one of the first laws of programming, is that lowering quality lengthens the development time. So by lowering the quality, we're going to take a lot longer to really develop the code and maintain it. So I'm a big fan of a philosophy which is slow down in order to gain speed. So if you really want to go faster, sometimes we have to slow down in order for us to be able to gain speed. If we are going at a breakneck speed all the time, that might end up in a disaster. We may end up in a ditch, for example. So there are times when we have to negotiate and go slower, and improving quality is one of those moments where by slowing down to improve the quality, we begin to really be able to go faster in general and gain speed. So that's one of the reasons. So if you want to go faster, you really want to slow down to improve the quality. One other reason I would mention we really want to focus on quality is, what is agile development? Agile development is the ability to change. That's what it really comes to. Agile development is being adaptive. That's the core of agile development. So in other words, I would say that we can't be agile if our code stinks. So essentially, you are sitting in this meeting and they are talking about the need to modify an XYZ module. And as they are saying, we need to modify the XYZ module, you remember that the last time your team touched the XYZ module, nobody could go home for the weekend. You are going to convince people, no, we don't want to make that change right now because that's not something we can quickly modify and get it back to working. So in other words, you really cannot sustain the pace of agility and provide change if the code is of very poor quality. So if you want to be agile, if you want to be able to sustain the development process, we need to be working with a good quality code. In general, that becomes extremely important as well. But it also comes down to humanity. I will say, good code is about empathy and humanity. So you are walking down the building and you push open the door, and what do maybe without even realizing? In a civilized society, as you walk through the door and you push the door and you step out, ever so gently you hold the door just for a moment, and maybe you turn around and look in case somebody is right behind you so the door doesn't slam on them. And then of course you hold it long enough for them to get a grip of the door, and then you walk away. And you do this to the absolute total strangers that might be walking behind you. You may have never seen them before, you may never see them after, and yet you have deep down an empathy and humanity to hold the door just for a moment. Well, every time you push the door, you want to make sure it doesn't slam on somebody behind you. While every time you push the code, you don't want it to slam on somebody behind you either. So the next person who is doing the pull request, you think about them. That is humanity right there. So essentially, when it comes to, I'm going to say, code is how we convey how we feel about our colleagues. So do we love them, or do we hate them all? Well, if we really feel good about our colleagues, we want to write code in a way they can maintain the code. You want to tell your colleagues, I love you all, I feel great working with you. Let's make this easier and wonderful for each one of us. That's basically the idea of writing better quality code. It fundamentally comes down to humanity and empathy. That is extremely important. And of course, it also has a very big impact on the economic impact on software development. So when we develop code, what is going to be the cost of maintaining this code? So oftentimes we realize we write code once, but we change it. We change it and read it many, many times over and over and over. So I'm of the firm belief we can never, almost never, write a code perfectly in one sitting. We write it and we come back and improve it. We have to add features, we have to fix bugs, we got to make enhancements. We constantly read code more than writing it. And so we want to really optimize. And that is the key here, is optimize for reading rather than writing the first time. So essentially, that is basically what we want to really focus on when it comes to really good quality code, is the ability to really respond to it. So what does it really mean to write a good quality code? And I would say a good code reads like a story, not like a puzzle. So if we write a puzzle, we don't have a clue what the code is doing. We are scratching our head trying to figure out what this code is doing, but I want the code to read like a story, not like a puzzle. When you read the code, you quickly understand what the code is doing rather than having to figure it out. So we want to really ask the question, how can I make this code really better from the point of view of understanding? So, in everything we do, when we write the code, we are simply trying to put things together to make them work. So I'm a huge fan of this mantra, which is make it work, make it better real soon. So you want to make something work, but then you want to come back and make it better real soon. And so, write the code, but before you move forward, just pause a minute and ask the question, how does it feel from the point of view of somebody reading this code? So look for the flow in the code as the very first thing. Does it logically move the reader forward from the unknowns to the knowns that they can gather along the way, so it becomes easier for them to understand what is happening in the code? So look for the flow to begin with. So what are some of the ways in which we can improve the quality of code? So we talked about what is quality. We talked about why quality is important in a few different angles. And we all have personally, every single one of us who has developed software know this already in terms of the pain that we inflict on ourselves by writing poor quality code. So there is incentives to really write better quality. And yet, knowing doesn't translate always to doing. When I speak in conferences, in person, or I have the ability to really get feedback instantaneously, I would often ask the developers attending, I would ask the question, how many of you think long functions are a good idea? And I would get back a resounding no, we don't want long functions. Then a few seconds later, I would ask the same group, how many of you have seen long functions in your own code recently? And the same very people who said no to writing long functions would say, yes, I see long functions in code. How is it that we collectively as an industry know that writing long functions are a bad idea, and yet we see them in our own code base? Well, that is cognitive dissonance. So knowing something doesn't translate to doing something. We have to put a little bit more effort. We have to motivate ourselves, but we have to motivate others as well. So we direct ourselves to do better things. So this is where we can collectively benefit from each other. I may not really have the motivation today, but you may walk in and say, how about really doing this? Well, that is a way to get motivated to do the right thing, and collectively each of us can motivate each other. So here are a few things we can carry home to really improve the quality of code. The very first thing I would argue is focus on the relevant. Everything else to me comes secondary. What is the point in writing really, really great code that is not necessary? So the very first thing, I'm a huge fan of this question that I keep asking myself, and that is minimalistic code and design as well. I am the minimalist. I want to minimize as much as I can the things I'm going to be creating. So I will always ask the question, is this necessary? Do I really need to do this? A minimalistic design, a minimalistic approach is highly essential. So essentially asking the question, does the application need this? This is not only about the code we are writing, it's about the edge cases we want to handle. And more important, this is about extensibility that we often focus on as well. So how do we make sure the code is extensible? Well, the first question we want to ask is that extensibility even really potential or possible, or how highly is it probable? Those are the questions we want to start with. So the very first thing I would say is look for the relevant. When you look at the Agile Manifesto, they actually said create working software, they said. But I really think they seriously forgot to mention a word in there that they really meant to have. And to me, that is create, and the word that's missing is relevant. So you want to always create relevant working software. I think most of us are now capable of creating working software, but is it serving the needs of the business? Is it serving the needs of the customers? Does it provide value? And can we provide that value by writing more minimalistic code and design? That's a question we want to constantly ask. Is it relevant? And so let's focus on what's relevant. If we
We
write,
have a question.
oh yes, please,
I'm
absolutely.
sorry. Yeah. What is your opinion about John Questerhout's philosophy of software design, in which he states that long functions are not bad as long as they are cohesive?
So I would disagree with long and short because it's quite misguided to think about long and short or cohesion that way. The misguided notion here is looking at a function in terms of the number of lines of code in the function. What you really want to focus on, I often say SLAP is greater than SRP. SRP really is about cohesion oftentimes, but I don't focus anymore so much on SRP on cohesion. I focus on SLAP, which is the single level of abstraction. So to me, the question I often ask is, are the functions, the instructions in the function in the same level of detail? So that is what I really want to focus on. If everything in the function is the same level of detail, I'm not going through this cognitive load of switching from one level of detail to another and back and forth. That is what I really want to focus on. I spend more time on this in my workshop, which I have tomorrow, but essentially the idea is you want to think about not the length of a function, if you will, but look at the number of levels of nesting in the function. So it's kind of funny to think about it. It turns out the length of the function is not vertical. The length of the function is actually horizontal if you think about it. So it's the number of levels of detail that is in a function. If a function is able to delegate the responsibilities to other functions, then it tends to stay in one level. And this leads to what is called the compose method pattern, and which is what I really focus on when writing functions, is that the function should be composed with instructions at the same level of detail. So I encourage developers to think a little bit beyond cohesion, because if we go with the argument, it is okay, we are really misguiding people to say, do it and justify it. Instead, I would say, go with the asking the question, what are we trying to convey in a function? If we convey in a function only the details at one level, then we are not getting into this argument as to is it okay or not, but instead we are focusing on conveying in a way that it becomes easier to understand. So that's what I would say, focus on the levels of detail rather than the length of the function itself, and make sure it's in one level of detail, one level of abstraction. That usually leads to a better quality code. Thanks for the question again. And again, I encourage you to have more of these questions and comments along the way. I would rather listen to your questions and guide the topic to that rather than rant away myself. So please do continue to ask those questions. I really, really am thankful and appreciative of that when that happens. So we talked about focus on the relevant, write code that really solves real problem and keep it minimalistic. So this goes to this idea of parsimony. So parsimony is to really go towards this minimalistic design. That's one way we can improve the quality of code. In the same token, be mindful of the extensibility trap. I cannot tell you how many times we have written more code and more complex code, and the one that's hard to really maintain because we want to make the code extensible. So the question you want to ask is, what about extensibility? So extensibility is highly important, but where misused, ends up with unnecessary complexity in general. I'll use a very crude analogy over here. I'll say code is like people on a crowded train. If you're in a very highly densely populated city around the world, whether it's New York City or Bangalore or Tokyo or any other cities, you probably know the pain. If a train is crowded, it's incredibly hard to get in. The people on the train make it harder for people outside to get on it. It's a similar way about code as well. The more code you have, the harder it becomes to add the code as well. So one way to really plan for extensibility is to go towards a minimalistic design. So don't try to make things extensible just arbitrarily. Instead, make it extensible on the situation when you have to make the first change. There is evidence of what you need and accommodate those in that case. So be very mindful of this extensibility trap. In the name of making code extensible, if we arbitrarily start designing towards extensibility, we in general make the code much more difficult to extend in the long run. It's the very set of things we set out to improve really comes back to hurt us, and you want to be a bit careful about it as well as you go along.
Here is another question.
Yes, please.
Talking about extensibility, would you say that OCP sometimes causes us to expose too much of the implementation details, which makes code harder to refactor down the line?
I would change the word sometimes to when used dogmatically. I come across so many programmers who say, but wait, I have to apply these principles. And I always say, no, you don't. You want to apply the principles in the context of relevance to application and the domain. So this is where it pains me when we start using principles for the sake of using principles. So using principles without context leads to unnecessary complexity. So this is one of the reasons why, whether it's open closed principle, or whether it's even single responsibility principle, or whether it's a dependency inversion principle, or even the dry principle. Every single principle has to be used in a context of the application and the domain. And I've seen to the question, I violently agree with that, in that I've seen developers complicate code a lot more by using the principles. You could ask me, what is worse than using the principles? I would say it's using design patterns. I cannot tell you how many times I've seen developers use design patterns and you're scratching the head, but why are we doing all of this? There's a simpler solution to solve the problem. And they are like, but I want to use these patterns. Like, why? So arbitrarily using patterns and principles can lead to unnecessary complexity. These are really good tools, but we need to really know when to use those tools. And if we are misguided in using the tools, it can end up with complexity. So absolutely, we have to be very careful using those things. One problem I've seen the most extensive is dependencies. Now, this is not just the dependency to external libraries, but dependencies in code as well, like a one function depending on another function, or one class depending on another class. These kinds of dependencies are problematic as well. So when it comes to dependency, we want both, and in this case, we should strive for both low coupling and loose coupling as well. So low coupling is necessary, without regard to the language we are using. So in other words, we want fewer is better than a lot, when it comes to dependencies. So we want to really lower the dependencies as much as we can. Why? Because it really comes down to the frequency of change. If a code depends on many things, it has to change more frequently. If a code depends on fewer things, it would have to change fewer number of times. So the code is more stable. It really comes to stability, and also you could say, so stability and frequency of change are really the reasons why we are interested in this. So frequency of change and the stability of code, it becomes relevant. Having said that, though, when it comes to loose coupling, depend as much as possible on stable things. For example, like interfaces, than unstable, or you could say less stable is probably a better way to say stable things. For example, like classes. But I would say this is really more to do with, more so with, you could argue, in general, statically typed languages, if you will. So typed languages compared to more than if you could say dynamically typed languages. So essentially, you can say dynamically typed languages are a bit more natural in terms of how they are adaptive to a bit of a loose coupling compared to statically typed languages. Statically typed languages tend to really lead to this issue a lot more. So low coupling is essential in any language you program in. Loose coupling a little bit more so in statically typed languages than dynamically typed languages, if you will. That is a concern. We need to really think about it. But one thing I wish we can do more is, I would challenge you to do this. A sign of poor design is if you see a lot of stubs and marks in your tests. Now, of course, I'm assuming we do fairly good amount of automated testing, but if your automated test involves a lot of stubs and marks, that's a sign of poor design. I always like to keep an eye out for it. If in my test suite, if I see excessive amount of marking and stubbing, don't assume I'm saying that don't use stubs and marks. That's not what I'm saying. I use stubs and marks, but I want to keep it minimum as much as possible. So one recommendation I often follow is remove dependencies as much as possible. And that's a first thing. That's my very first, approach. The second approach is move dependencies, as much as possible to higher levels. So the interaction becomes more coarse grained rather than, if you will, fine grained. So essentially, if you move the dependencies to a higher level, your interaction that your code has with the dependency can become more coarse grained and less frequent rather than fine grained and highly interactive. The first one, obviously, removing dependencies removes the need to mark and stub, makes testing easier, makes design much easier as well. The second one, when you move the dependencies, it reduces the stubbing and marking quite a bit as well. The third is, of course, stub and mark for testing, but minimally as much as possible. So this is again, as much as possible, we can reduce this. So when it comes to designing, don't look at the problem and say, sure, this code requires this data. Let's go. Let's bring in the dependency to get the data. Well, the application requirement says we need to provide this particular behavior and functionality. It is between you and me to sit down and design this so that we can keep those interactions as minimum as possible and make the code a lot more stable while providing the functionality the user is expecting. So we want to really design and redesign and refactor to reduce the impact of dependencies as much as possible. So a good code would deal with minimalistic dependencies. Part of the reason for this is that not only with the more dependencies we have, if the code is brittle, it also becomes harder to test it. This is one of the reasons I love automated testing. So automated tests, often, if you will, so automated tests often are early signs of design quality. So usually when you write automated tests, if it becomes harder to test this code or takes more effort to test this code, that's a sign that we need to improve the quality of design. So it's important to really listen to those as we're writing test cases rather than plowing through it and saying, hey, you want to write tests? Let's write tests. No. Tests are, I often say that tests whisper in your ears. As you're writing tests, they whisper in the ear saying, excuse me, this is not really helping here. Do you want to reconsider what you're doing? We want to listen to those whispers that tests have. And when the tests whisper, we should listen. And when we listen, we improve the quality of code. That's one of the reasons why I really like these automated tests. More so, the whispers of the automated test are really important to listen to. The next point I want to make here is write clear code rather than writing a clever code. So the more clever code we write, the harder it is for us to understand in the long run, for others to understand. But why do we write clever code? We write clever code fundamentally because we feel good about it. That proverbial hand comes and pats us in the back and says, you are awesome. This is wonderful. Well, guess what? That wonderful and awesome fires back at us. That every single time now, when I write clever code, I immediately refactor it and I make the code clearer, because a clever code feels great when we write it, but becomes incredibly difficult to maintain it later on. So strive to write clear code rather than clever code. I remember one experience I would never forget. One of my clients wanted me to make a change to the software to address a particular small change in the feature. I looked at it. It would have taken 10 minutes to make this change and get it ready. But I said, that's beneath me. I don't want to solve this problem. I want to solve the mother of all problems. I am going to do meta solution for this one. And so I solved the problem and the problems that may appear in the future, making it extensible as you would expect. A couple of weeks go by and I see a email trail that talks about a major problem that's happened in production. I looked at it and I immediately went back to them and said, I'm going to fix it. And they said, oh yeah, we know you can fix it because you're really good at these things. I said, no, 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 no. I'm going to fix it because I am the one who caused it. That wonderful solution I put in place is backfiring in ways I never thought it would actually backfire. So it's very important to really be careful adding clever solutions and make clear solutions that really solve the problem as we understand it. I think there was a raise of a hand. If there's any question or a comment, I would be delighted to hear that along the way as well. So as much as possible, focus on creating clear solutions rather than making clever solutions. That, generally speaking, helps us a great deal when it comes to writing code. The next thing I'll talk about here is don't cover up bad code with comments. I cannot emphasize how much I really dislike comments that tell me what the code is doing. So do not write comments that tell what the code is doing. So this, unfortunately, is a problem in our industry where we have been misguided along the way and we've been told to write comments. I cannot tell you how, every single week, some senior developer, chuckles and says, I really wish they wrote comments. These are senior developers telling me, I wish they had written comments. And I always, discuss with them and I say, no, I don't want comments. So I say, do not cover up bad code with comments. Instead, I would say refactor. So I want to refactor bad code, not comment it. No, I'm not saying never write comments. What I'm saying is comment the why, not the what. So tell me why the code is designed this way. Maybe you are using a particular data structure at this moment. Why are you using that data structure instead of maybe something else? Is there a specific reason why you are heading in this direction? Tell me those things. If this code will work only under a certain situation, or maybe there are limits to this code, mention those in the comments so that is useful. But don't write comments. Now, I'll give you one example of this. I also part-time and teach at the University of Houston. While I work in the industry most of the time, my late evenings and early mornings, usually I spend time with the students at the university reviewing their code. And one semester, this was maybe 5 or 6 years ago, a student joined the class and said, this student had 15 years of experience working in the industry. And I absolutely respect anybody who joins my classes. This particular student is taking my software design course, has 15 years experience. That's great. Well, I do a lot of code reviews every single day for my students in my class. And one consistent thing I do in the beginning of the semester is when students write comments, I tell them, remove these comments, instead change the variable name like this or a function name like this so it's easier to read. Well, in this particular case, about the 2 or 3 weeks or 4 weeks into the semester, the student emailed me and said, listen, you keep telling me to remove these comments. I come from experience in the industry. This is what we do. We write comments for code, and you keep telling me to remove it, and that's annoying. And I replied to the student saying, well, fair enough. You are interested in writing comments. I don't like to see comments that tell what the code is doing. So why don't we hit a compromise? Next time you write a comment that is worthy of it, and if I remove the comment, the code I cannot write the code in a way that I can understand what the comment is saying, then I will accept your comment. So make the comment worthy and convey what cannot be conveyed in the code. Well, for nearly one full week, there was no comment in the code from this particular student. And after that, here's what I saw. It said, the student said, class, whatever my class, right, based on the domain name, it had implements comparable of my class, and then // this class implements comparable interface. And all I did, honestly, is the following. I went back to this code and all I said was, really? That's all I left as a feedback, right? And that's the last time I saw a comment in code from that student. Now, the point I'm making here is we have gotten into these practices by way of habit because there is a corporate police. And in the case of a university, we probably started learning programming in school or university, and professors are terrible at this. They teach bad practices to us. I'm a faculty part-time as well, so I will tell you, sometimes we learn bad practices in school. And the professor says, if you don't write comments, I will fail you. We're like, oh my God, I want to pass this course, so professor, I'll write stupid comments. Then we go to companies and there's corporate police. They say, if you don't write comments in code, no bonus for you. Now we are like, oh my gosh, this, by the way, is called TDD, where that TDD stands for, unfortunately, a threat-driven development. So we are unfortunately going through a threat-driven development where we are threatened to do things and we do bad things as a result. So comments are one of those things we've been threatened to do over time, and we get into a practice, and over time we forget where that came from and we just blindly follow it. It's a practice we want to break out of. So I would say comment why and not what as much as you can. I would rather write self-documenting code, and the code that is easier to understand, and quite a number of times, a self-documenting code, and also tests that tell what the code is doing, and how it behaves. So in other words, tests are a form of documentation. When I wrote the book on Java 8 functional programming, the first edition, the book was published the same day that Java 8 was released. So I actually started writing the book 2 years before Java 8 was released. And there was no Java doc when I started writing the book on Java 8. So in all honesty, and with great humbleness, I say this, I would download the source code and read their automated test. I learned Java 8 functional programming by reading their tests they were writing as they were developing the Java 8 features. So tests are a great form of documentation. But refactor the code continuously along the way. And this is where I was mentioning the make it work, make it better real soon. So every little thing, it doesn't have to be a massive thing. We learn every day. I'm a better person today than I was yesterday, and because there are things I've been learning every single day. So when I look at my code today, there are improvements I can think about. I can make those improvements and I can move forward. So refactor continuously to improve the quality of code. But I'll end this with 2 recommendations, and that is look at your technical debt, but 2 things related to it. We all have technical debts, no doubt about it. So it's pointless to ask, do you have technical debt? We do. But my first question is, can we see them? So in other words, list them in the order of diminishing impact. So in other words, the most troublesome to the least. So list them. And where do you put them in? If you're working in person, put them in your break room so everybody can see it. If you're working remote, put them on your dashboard for your team so everybody can see it. So the first thing is list your technical debts. And when you list your technical debts, so when you list the technical debts in the order of diminishing impact, when you are sitting and coding on that Wednesday afternoon, you look at the list and ask the question, do I want to take the shortcut and do I want this code to end up on the wall next week or the week after? So the first step is to list them in the order of diminishing priority. The second is schedule time to pay the technical debts. So essentially, take the time to pay the debts. Next sprint, 10% of the time, Sarah will spend on the first technical debt. The 10% of the time, Sam is going to spend on the second technical debt, and so on. And we're going to be spending time, part of our time, to pay the technical debt. So when we list them and start paying them, the team begins to realize if we take more shortcuts, we're increasing our debt. And when we increase our debt, it has to be purposeful, not by way of negligence. So there are good debts and bad debts. For example, if I write poor quality code, that's an act of sabotage. I shouldn't be doing it. I shouldn't say, yeah, let me write this, I'll come back and fix it. No, take the time to write better quality code, better quality test cases. But this library and the framework I'm using, well, they are evolving and they have changed the version. I need to spend the time to upgrade my dependencies on my code to the newer version. That's a technical debt. That's a debt I cannot avoid, but I need to pay forward as I move forward and plan for it as well. And finally, I will end by saying, do tactical code reviews. I'm a huge fan of code reviews. You say, oh my gosh, I hate code reviews because it's very punitive. Somebody comes in and argues endlessly with my code. Those are not very useful. I mentioned tactical code review. So what I mean by tactical code review is when one person writes the code, one other person reviews it. I don't have the senior and junior differences. Anybody on the team willing and able should be able to review the code. There are times when you want the code written by any developer to be reviewed by a junior developer as much as a senior developer. If this junior developer is not able to understand it, well, that's a sign the code is of not good quality as well. But when it comes to code reviews, I'll mention two things that I found to be extremely valuable. The first is I don't review code to begin with. And what I instead do oftentimes is start by reviewing tests and then review the code. So I always start by reviewing the test first, then I review the code. If there are no tests, that's my first review. Dude, where are our tests? Let's write tests before we move forward. Then the next one is, what is the quality of these test cases? If the test is of not good quality, we want to improve it. So review the test first, then review the code. The second recommendation I have here is when you find a bug, don't write about it. Instead, write a test for it. So essentially, I write a test when I find a bug rather than writing about it. This has been an incredible experience when I started doing it. When I find a bug, I write a test. And the test fails, I push the code in, and the CI build fails. I'm perfectly okay with that. It's okay to fail the build. What is not okay is to leave the build broken for a longer time. So when I push the code in, the developer who wrote the code initially gets a notification and says, oh my gosh, a code I wrote is failing the test. Let me see what's going on. aha, there's a newer test that Venkat wrote when he was reviewing the code, and they go and look at it. The first time I did this, the programmer came to me after an hour and said, hey, I see what you did there. I said, what did you notice? Well, you wrote a test that failed because of a bug you found, didn't you? I said, I did. I hope that's useful. And he said, did you know there were 3 bugs in there, not 1? I said, no, I did not know that. I only found 1. He said, yeah, when I looked at it, I realized there's more bugs in it. So I wrote tests for those bugs before I fixed it. I hope that's okay. And I said, my job here is done. This is exactly what I want to convert as a behavior for the team, is when you find a bug, write a test for it. Don't fix the bug yet. Write a test for it, then fix the bug and move forward. Then the test is there watching over the code. And if this bug were to creep up anytime in the future, the test is there to look for it as a defense. So in other words, when it comes to code reviews, it's not about whose code is better. It's all about how can we improve the code collectively and learn from each other. So review the test before reviewing the code. Write a test when a bug is found, and let the team work together in writing more tests when they find the bug. We can elevate the team constantly by doing so. So I discussed a few practices here that can help us to improve the quality of code. Not all of them in how do we write the code, but it also is how we can work together as well in improving the quality of code as well. I really hope you were able to take a few things back to your own work and apply that as you work in teams and lead teams and motivate yourselves and motivate others as well. I thank you so much for joining again. I hope you found it useful. Stay well, and thank you.
Thank you so much. That was really nice talk. And I can assure you in the Slack here, I can see a lot of love for the talk. People clearly enjoyed it a lot.